Hi, so my name's Charlie Newman, and this is my final project for CIS 9467. I wanted to create a solver application that related to my real life. Unfortunately, I don't use solver that much in the current line of work that I'm doing, but I did have an upcoming trip planned, and I wanted to be able to utilize solver to create an itinerary that would maximize basically my utility of the overall time spent while in Bangkok to really figure out how to create an ideal group of activities. So what I looked at, I did some destination research really using what I was able to find through TripAdvisor, and I took things into consideration such as cost, basically the amount of time it would take per day, and then I also kind of created a little kind of fun scale, on a scale of 1 to 5, how much fun I thought that activity would be. And then I basically created the decision variables that were set as binary, so a 1 for yes and a 0 for no, and those are going to be some of the decisions that we make. I set my kind of desired levels. Here is the maximum that I felt it could be, and then down here I did a sum product so that it would basically take each of those costs, and then it would go across to the binary cells and figuring out what the total level was. So once we figure that out there, it will automatically bring it over into this cell here, and then the amount above goal and the amount of below goal are also variable cells, because what we're ultimately doing is trying to minimize the penalty points. So once these decision variables are made, it's then going to translate to the level plus the goal, and then here you'll bring it into another sum product. Here the penalty will bring it into a sum product that will take the penalty points if above or below the goal based on those cells. So really we're trying to minimize the total penalty by taking into consideration a number of different factors, and I weighted the penalties slightly differently just based on what I wanted to get out of the trip. So the penalty is basically, the budget of not spending more than $265 is 1 point per dollar. So if you look at it, if you're staying in Bangkok another day, it's going to be about $66, because that was kind of about the daily amount of money that I spent. And then I figured below that, having some free time isn't really that big of a deal, so I kind of halved that relatively to the points if above. Again, if we were below a certain level of fun, then we would have some penalty points. And then I added in that I didn't want to see more than 2 temples, just because we had 3 temples on the list, and I wanted to make sure that we had variety. So once we kind of input that data with all the formulas, I go to solver, and you can see here that I'm minimizing the penalty box subject to the by changing the variable cells that are highlighted here in yellow. I set cells G4 through G13 to binary, and then basically all of these constraints are based on the goal right here. So you can see that this actual amount needs to be constrained by the goal. So we're going to press solve and see what comes up. So the solution that I received for this was basically I had a total penalty of 77.5 points. And my penalties are really just incurring from my fun level, which is a good thing. So I'm staying within my budget. I have three and a half days of activities, and I'm not seeing more than 2 temples. So the amount of fun that I guess I'm having is really at a level of 24.5, which is about half of the total fun, I guess, that I could have on this trip. So basically the items that it selected were this Temple of Emerald Buddha, the Grand Palace, the Bangkok Bike Tour, the Temple of Dawn, some spas, Museum of Contemporary Art, and then Canal tours. So some of these ones that are costlier and also not as fun were the ones that were kind of taken out, as well as this Temple of Reclining Buddha, which probably could also be interchanged with the Temple of Dawn because they have exactly the same rating. So this was just an interesting way to look at a fun way to play with Solver and kind of, add in different kind of constraints and see what you wanted to do. So once I did that, I also kind of thought about like, oh, well, what can I, what other kind of everyday choices could I use? And so what I looked at was one of everyone's favorite, Seamless. And so I put in a, I set it so that it was close to my home, and then as you can see, there's actually already a lot of different ratings that you can kind of pull up in terms of, distance from your house, the ratings of the stars, how much it costs on a scale of 1 to 5, and so I built a restaurant selection that has 10 different restaurants, and again these were going in alphabetical order, so you can really select any restaurants that you would want. And then basically the cost scale, it was out of 5, so I just kind of gave it a percentage point there. The rating scale was out of 5, so I gave that those points there. The distance from home was really listed in there, and then I added this just because I wanted to make sure that it only picked one restaurant, so it has one allocating to each of the meals. And again, same thing, same formula, getting the sum product for each of this to determine what the actual levels are. And then once we kind of put it in there, we set the goals. Again, I set the goals kind of right at the middle, because I didn't want to spend a ton, and I didn't want to, I wasn't really concerned about eating, the best option. I didn't want to travel more than a mile, so I kept that at 1, and then I wanted to keep it at 1 restaurant. So again, I applied different penalty points. As you can see, wanted to minimize costs, so if it's above that 0.5, then there is a penalty. If it's below, then there's not. I want it to maximize rating, so if it's above a 0.5, there's no penalty. If it's below, then there is a penalty. I didn't want to travel more than a mile from home. And then the 1 restaurant, again, just to make sure that it stayed at that 1, I really kind of increased the penalty to make sure that that was the most important part. So really, when you go to data and you run Solver, the constraints are all very, very, very similar. It's really the same kind of problem, just kind of applying it in a different way with different constraints. And so you'll run this, you can get the integer solution, and hopefully it will come up. Yes, this is the selection that it chose, which is Aperture Italian Restaurant, which you can see I'm actually not even getting any penalties, which is great. So it was able to stick at that 1 restaurant. I was able to find, living in Park Slope, you can find so many restaurants, but this it's still getting you the maximum of what you're looking for without those penalties. So as you can see, it's 0.6 on the cost scale, a 5 out of 5 stars rating, and it's only slightly over. So basically, yeah, this is just another way that you can kind of see here. And again, they are kind of going a little bit above and over the goal, but not where the penalty points are hitting it. So just kind of a fun way to use Solver in, some everyday decisions that you could want to make, and just something to really kind of play with and look at some different tools that you can use within Excel. So thank you very much for listening, and hope you enjoyed the tool. Have a great night. Bye.